Today I am deriving the important relationship, that is Ohm's law, from the concept of drift velocity. So first we have to know the basic idea of drift velocity. First of all, drift velocity concept has given in the previous classes. Today I am given shortly. All students are requested to watch the previous classes. First of all, we know that is a metallic conductor consists of a large number of electrons. These electrons move in different directions with different velocities. So average velocity of electron is 0. When applied potential is given, then electric field is set up, and then electron move from one side to another, that is minus terminal to plus terminal, and current flows in opposite directions. So from this concept, that is from this concept we get the idea of drift velocity. So electron are moving with average velocity from one side to another. This velocity is known as the drift velocity. From this concept we have to derive V equal to IR, that is Ohm's law. So first of all we have to write down a metallic conductor consists of a huge number of free electrons. All electrons move with different velocities in different directions. Let U1, U2, U3, UN are the velocities of electrons, that is first electron, second, third and nth electron. So average velocity denoted by U equal to U1 plus U2 plus U3 plus UN by N equal to 0. So average velocity of electron is 0. So if I draw a conductor, this is the length of the conductor and A is the area. Potential difference is applied in such a way, that is V, here that is plus, that is minus, current flowing in this direction, electrons, there are a lot of free electrons are moving from this side to this side. This is the direction of electron. So when potential difference is applied, when potential applied between two ends of the conductor of length L and cross sectional area, that is A, then electric field, that is E, is set off. So we know that is E equal to minus V by L. So electrons, here the electrons are drifted from minus negative terminal to positive terminal, as shown in figure. Electron drifted from this side. The current flows from positive terminal to negative terminal of the source. This is of the source. Of the source. So current, actually the electrons, that is free electrons move from low potential, that is to high potential, that is, this is from minus to plus with average velocity, with the application of electric field. This velocity is known as drip velocity. This velocity is known as drip velocity. The electrons gain energy and accelerated by the source. They collide with each other. they collide with each other. So they collide with each other. So that is force on free electron, that is an acceleration of free electron, that is minus E by m. So we know, so acceleration A equal to this, putting the value of E, we get that is EV by ml. So let tau 1, tau 2, tau 3, tau 1, tau 2, tau 3 be the average time interval, average time interval between successive collisions, So that is for 1, that is for 2, that is for 3. If we consider that is n, that is tau n. So we can write that is V, we can write in this way. If I consider that is Vn, nth electron, then we can get the value that is here. We get the value here. If I consider nth electron, then in this case here. Next we have to know the average velocity. So next we have to know the average velocity. So average, show the average velocity that is Vd. So Vd equal to, we can write that is U1 A tau 1 plus U2 plus A tau 2 and plus Un plus A tau n divided by, that is n. Here that is Vd equal to, so Vd equal to, we can write, so Vd equal to, we can write that is U1 plus U2 plus Un divided by n plus common A, that is tau 1 plus tau 2 is tau n divided by n. So this is 0, we proved previously. This is known as the A tau. So Vd equal to, that is A tau. So magnitude A tau, tau, that is relaxation time. Please watch the definition of the relaxation time in the previous class. I give the link in the description of the previous class. Now we know that is Vd equal to putting the value of A, that is EV by ml into tau, putting the value of A from previous equation, that is Vd. So this is the value of, that is Vd, and so we have learned the what is drift velocity. So again, this is the, I take, this is relation number that is 2, this is relation number 2, and we know that is I equal to NEA Vd. This is equation number 3. This is equation number 3. So putting the value of Vd in equation 3, we get that is I equal to NEA E into V by ml into tau. So we can get the value that is N square A by ml into V multiplied tau. So this is the relation. So here that is N square A tau by ml, that is 1 by r, that is r equal to ml by N square A tau. So putting the value of r, that is 1 by r, that is V. So V equal to IR. From this we can get the V proportional I. So this is the Ohm's law. This is the Ohm's law. Here R, this is the resistance of the conductor. This is the resistance of the conductor. So from this concept we can get a very important conclusion. So we get that is R equal to ml by N square A tau. This is the value of, we know this is the value of R. This is the value of R, that is ml by N square A tau. Again we know that is R equal to rho L by A, R equal to rho L by A. So we can get, putting the value in this equation, that is ml N square, that is A tau, that is rho L by A. So we can get the value, that is rho, L cancel, that is m by, so m by N square, that is tau. So from this concept we get that is rho proportional 1 by tau and rho proportional 1 by n. So resistivity rho, that is resistivity of the conductor. So rho depends, that is tau, collision relaxation times. Rho depends, that is n, that is number of electrons per unit volume. So rho has different value in different substances, and from this equation we know that is rho equal to 1 by sigma. তাহলে sigma equal to, we can get, that is n square tau by m. So sigma proportional n, sigma proportional tau. So this is the relation of sigma with tau and sigma with n and rho. So we have got a complete idea from deep velocity to Ohm's law, and from Ohm's law we get the sigma and rho. Sigma means that is conductivity of the conductor. So from this relation we can easily conclude that rho and sigma depends on the nature of the material, because this difference, that is n. So sigma and conductivity, that is sigma, that is conductivity, and rho, that is resistivity, depends on the different type of substance. So today's class has been ended. I think this class is very much helpful for each and every student. This is very useful for different type of exam purpose. This is very important topics. Please watch all the videos, like, share and subscribe. Thank you all my dear students.